I want to introduce Cody Wallis with Automation X, and he's going to be talking to us today about Sensi Plus.
Awesome. All right, so kind of as an introduction, like she said, my name is Cody Wallis with Automation X. Been in the oil and gas industry roughly about 17 years. Background from drilling rigs offshore, coming on the land, with a few production companies. Based out of Texas, I've always been in Texas, but I work for Automation X and kind of cover all across the U.S. and supporting products that we sell, but also our internal staff and training and things like that. So before we get started, I want to kind of get a feel for the crowd. For you guys, how many of you guys are in upstream production in the side? 1, 2, 3. What about midstream? Midstream side? And then downstream? So we got some utility guys in here? Oh, awesome. Awesome. So before we get started, I need one volunteer. One volunteer to step up for the class. What's that? This guy right here. All right, come on up. Come on up.
I'm going to need 2 of those at least.
You're good. You're good.
Left or side.
So the way I want to start is I want pretty much the interaction. So you people involved, you got the easiest one in the class. So for your volunteer, you get a 25 first shit. That's it. So like I said, the whole point of this class is for you guys to learn, to kind of help interact and keep it up in fun class. So ideally, it's not all about just being that stuff. We want you guys to learn. We want you guys to take away something from this. So today, what we're going to be talking about is ABB's, not new, but recently produced Sensi Plus. And so, how many of you guys are familiar with Sensi Plus, what it does? I mean, so from you guys' standpoint, everybody knows a gas converter, PGC. What is it doing? It's taking a gas in and it's telling you, hey, the quality of the gas. What is my gas worth? What is my methane? What are all my good attributes of gas? So the problem is typically, mostly on the upstream side, but sometimes in the midstream, downstream, you get some contaminants in that line. You get some unknowns, some bad things. So what the Sensi Plus does is measures those contaminants. So the way we like to put it is your GC, the gas area, is going to measure all your good stuff, all your good attributes. Alongside that, paired with that GC, the Sensi Plus is going to put all the bad contaminants that could be in your body. Do you want the contaminants in there? Do you want it measured? No. But in oil and gas, midstream, downstream, municipality, from time to time you're going to have offsets, you're going to have codes. So that's what this device is. So we'll get started with it. So basically what it is, so I have a single analyzer that is going to take one stream of gas in it, and it's going to be able to recognize that the current 3 contaminants, CO2, H2S, and H2O. I say this lightly, but supposedly in section 1, we're going to have 4 contaminants. And with this technology, nothing will change as far as the hardware or anything like that. But the 4th contaminant will be released, and that's going to go to. So a lot of customer bases are waiting on that too, because that's kind of one of those touchy things that from time to time you see in the field. So how does this, what brings this thing together? So it's a class 1, div 1, groups VCD, NEMA 4X modular platform. So it is what they call their ICOS technology, off-axis technology. And we'll get into what does that mean? What is ICOS technology? How does it work? What does it do? And how is it so accurate? And how is it so fast? So currently, like I said, it's scalable from 1 to 3 contaminants. So if you just need H2S, you just need to do a single contaminant, you do a double, you do a triple. From a cost evaluation, the more contaminants you have and utilize, the more valuable this thing is from both a cost perspective and a footprint perspective. So, for ABB, they're saying price competitive in all formats and superior in value. So what are they talking about in value? So whether you're using AMI analyzer, spectrum analyzer, all of those things have consumables and have to be maintained. This technology here, it's not 100% non-maintainable, but the replacement components and all those things are built in to where you're going to have longevity, you're going to have higher accuracy, and you're going to have redundancy built into this thing. And we'll get into that a little bit later. So power consumption. It says 10 to 30 volts. However, if you are using the analog output sorter to be able to send that value to a longer output, analog output requires 16.5 volts. So if you're below 16.5 volts, your AOs are not going to work. If you're doing TCP modules, you're perfectly fine with 12 volts. But from an ABB's perspective, they recommend 24 volts, even though it says 10 to 30. So that just covers the base of modulus, AOs, EOs, any of that. This one is the price. So it's single cell, multi-laser design. And then, so it has advanced diagnostics. And we'll get into that. I'll show you guys a few things, key things with that. Bluetooth is standard on all devices, and Wi-Fi is an option. So you can get this with or without Wi-Fi. You can enable this, and if you get it, and the company says no, I didn't utilize that, then you can disable it or remove it and be done with that. So, another big, I don't want to say selling feature, but a big feature of this device is when you look at the footprint of setting a H2S analyzer, an O2 analyzer, a CO2 analyzer, and an H2S analyzer. You're looking with the same condition for each one, and to do it right, you're looking at roughly an 8 foot wide by 4 foot footprint. The big selling point of this is the footprint is what it is. You're roughly 2 foot by 2 foot, whether you're doing 1 contaminant or 4 contaminants. So, and the last thing on this page is, it's real-time, full-time measurement. There's no scrubbers, there's no meters. That is better point on this device. Any questions so far? Good?
Can you hear it? Yes.
What's that?
Can you hear it? Yes.
No, so you're feeding in your live stream gas. So when we kind of break into it, we'll talk about the components of the lower compartment. So what all is there? On the optical side, you've got the optical cavity, you've got the mirrors, the laser, the detector, and the signal amplifier. So when we talk about this, what does the signal amplifier actually do? So I guess to kind of showcase this image, we're having 3 volunteers. You got a volunteer? Come on up. Come on up. Come on. And it's this side of the room. All right. So we got this guy, he's going to be H2S, right? This guy in the middle, we CO2. All right, this guy's going to be H2S. So here's what I want you guys to do. I want you to hold them out and close together. Okay, about the same height. And here's what I want you guys to visualize on this. These are all baselines, right? They all look the same, different color, so that's a characteristic of H2S, right? The other 2 balls basically look the same. So when I say drop the balls, you're going to drop them all at the same time, and we're going to notice something about these. All right, go ahead and jump. So what do we notice?
Gravity. One balance.
You got different patches, you got different things. So how is this thing like our playing into this? So all these characteristics, and even if we have another ball at a different characteristic, these balls would all have a different effect, whether how fast they fall, whether how high they bounce on that, how far they compress. So that's how these components work when they're going through this. So what happens, let me put yourself in real quick. What happens with this technology? You guys can go ahead and have a seat. Appreciate you guys. So what happens with this technology is when this gas stream comes in, okay, you got a single gas stream coming in. How is this recognizing all these contaminants all at once? Well, so what we notice with the baseball is they have different characteristics. Same applies with these contaminants. H2S has a different frequency breakout than CO2 and H2O, right? So as that stream comes in, it shoots in and the laser triggers every second. So every second, that laser is taking a reading of 200 readings every second. 200 readings every second. Every 2 seconds, we're going to get an output. It's going to give us an actual reading. So every second I get 200 readings. Every 2 seconds I have 400 readings that overlay each other, and they average out that give us the true reading of those 400. So that's the speed, and that's how the accuracy applies to the accuracy technology. So how does that work? So essentially, the OA accuracy. So OA is the axis. All that is a simple term of we're not flat, we're not open, we're in the angle, right? So if you shoot a laser straight back, dead set straight back, if you have a mirror, you're going to get a direct reflection back. So the way they do this is they want it off axis. So when it shoots into the glass and reflects off the mirror, it's basically creating a rotational pattern that is going off the mirror. So that's how the speed, because as it shoots across, it gets 1, 2, 3, 4, 5, 6, 7, 8, just in one little beam. So that's how it counts that fast. So integrated cavity output spectroscopy. This technology was a technology originally developed by a company called Sensi, based out of California. ABB came into play. Those companies knew they had the technology, really didn't know what to do with it, how to market it, how to develop it. Well, ABB had the market of NGC, gas chromatography. So they knew they had a need for this, and ABB took this on. And that's where this kind of developed them. So why don't they have O2? Well, so when this was developed and released by ABB, O2, the range of O2 didn't fit all markets, right? So more on the midstream, downstream, you got smaller margins, smaller range. But upstream, we didn't fit that market. So they decided it's better for us to just not release it at all, and let's get it right, so they hit all ranges, versus releasing it and saying, hey, you gotta work for you and more work for you, or you work for you and more work for you. So, O2 has been beta testing in the field for roughly, I think, 3 months now. Good results with the changes that they made, so that's going to be a new release coming forward soon plus.
How much H2S did you see?
We'll get to that. Just a second, I got to break out for that. So, a few details. Absorption spectroscopy could be a severe labor load. Portion of the laser power transmits through the front mirror. And if you see what it's doing, so the laser is shooting through the front mirror, and effective path of 100 S of meters per measurement cycle. So roughly 4,000 feet every second. 4,000 feet of readings every second. So and this allows for detection of low concentrations. So we'll get to the page where we'll talk about what is the concentration range that we currently have. So from the factory, it's got the exact alignment, it's got the exact inlet pressure set up, it's got the exact gas temperature that this can handle. But in the field, from a heater standpoint or from a setup standpoint, I've seen it as small as mounting a single wall within 5 minutes of the running wall the way you're leaving. So very robust, very easy to install, very easy to integrate into a platform. So multiple lasers can be used, alternating their transmission for the multi-component measurement with a single cell. So does a gas composition matter in this? ABB does require us or request us to, when we go to quote this or to work with the customer on this, they want to see gas levels. They want to see if there are any anomalies in this gas stream that could throw off something or give a false reading. So far, I know everyone that we've quoted, and I haven't heard any feedbacks from Marion or the other ABB channel partners of anything kicking back saying, hey, we're not going to, you can't use this sensitive close. So they're the early stage of release and their support behind that, they want to ensure that this product is going to market. It's strong for the customer. It's strong in its value. So moving on. So this is kind of outlines kind of how the off-axis ICOS works. So scan laser and then the laser transmission spectrum. So laser scans, you've got your baseline, and then you've got your cavity read down. So when the laser powers on, that second, that you kind of cavity reading down, what that allows us to do is get back to that baseline for that second shot. So the absorption spectrum, it goes through the absorption spectrum, and then you'll get your reading for the target based off of the baseline. And that's all ran through the ICOS algorithms. So these are proprietary algorithms enable quantification of multiple gases in complex mixtures, allows a single laser instrument to report multiple species simultaneously, no scrubbing or pre-treatment required, analyze complex spectra by measuring basis scent spectra and convoluted. So I've had a lot of people come out of the booth today and they're like, hey, what type of pressure can this handle? What type of pressure does it require? So low and high. So the ideal pressure for this thing is half of GC. So maybe using GC, roughly 15 psi. Ideal pressure on this is 7 psi. Well, can I go lower? It actually states that it'll do 5 to 8. ABB's recommendation is 7 psi. Will it operate at 5? They tested it, yes. Based off of the way the same condition and everything, the regulations on that, 7 psi is their recommended standard for the condition. So, right here we talk about measurement ranges. So, what is our measurement range? H2S, we're looking at 0 to 100. H2O, we're 0 to 500, and then CO2 is 0 to 40%. So, I'm trying to remember, I believe O2 is going to be 5 to 500. So, that's currently safe, that's what's being tested. Like I said, expected to be safe for that, except for the one. So, we'll see how that. So, if you look at the accuracy of these and the repeatability, high accuracy, high repeatability, and then everything for the training range is taken there as well. So let's talk about some of the components. So Ethernet capability. That's standard. You've got a USB serial port. You've got two digital inputs and then 10 digital outputs. So the way it was explained to me on the digital outputs and the analog inputs, each containment has two digitals and two analogs, right? So why is there 10? Well, the way it's designed, there's two that are proprietary to setting up for ABB specific. So if you set this up and you want to set up just a high level alarm and show you can do that with the scene. If you want to read an analog, you want a high and a high. So you get a alarm on your high and you get a shutting on your high. You can do that with certain the device. The other part is on-host TCP. So if you want to, some people trust communication over hardwiring or hardware. Just depends on the company, depends on the compatibility with the device and what it can do. Power supply, like I said earlier, 10.5 to 30 volts. Wi-Fi capable. We talked about this. The Chevrons of the world and Exxons, they don't allow any kind of Wi-Fi. Some of the smaller outfits, some of the midstream, they're all for new technology. It's not just an open air Wi-Fi. It's password capable. You can do a dual layer on the Wi-Fi where you can have a credential login and then a password per credential. So it has that capability as well. It does have Bluetooth. That's standard. We discussed that. D-rated Ethernet, D-rated USB, and then obviously the gas input, gas output ports. So, what is the typical mounting? What is the typical footprint of this? This is basically what it is. Like I said, we recommend, based off ABB's recommendation, go ahead and throw in a liquid block and plus smooth block with a membrane filter on the bottom side of this. It does come through the regulator, and then it does have a genie filter built in on top. But just for safety's sake, that's a recommended, it's not a requirement, but it is a recommended component to do this. Any questions on the components, capabilities? Good. Let me swap over real quick. So just full transparency, I bring up this valve card because it's not to dog any other company, it's not to dog any other product or that type of technology. But this battle card does have some value to it. It does kind of cross-reference different technologies, different products, different brands. Like I said, full transparency, this is not a dig or a jam in any other company. This is just simply saying what we're learning about today. I have to screw out of this. So when we talk about it, you see right here on the portfolio side, we talked about, okay, you can do single contaminant, dual contaminant, or multi-contaminant. And then going up against the competition, E&H has the SS2100, which will handle H2S, H2O, and then AMI is in the same boat there. They have the 3010BR and the 4010BR. And then Invent with the 330 and the 331. But once we get down to H2S and CO2, and then also H2S, H2O, there's really no competition out there that can do that simultaneously. So the value proposition is, what does it look like from a footprint? What does it look like from a cost perspective? for the end user. And then, we talked about the reliability. The reliability is there. The accuracy is there. Really what it comes down to is, is footprint something you're dealing with? Is availability. Do I want to have two ancillary devices that I have to maintain? Maybe it's different software, maybe it's different technology where I may have to change the lead acetate tape on one, and then I may have to change a membrane inlet on the other. With this unit, it's an all-in-one, and here in a minute we'll kind of get into the breakdown of what does that field maintenance look like on this unit. So markets served upstream and midstream, pipeline operators, processing, storage, and biogas. Is anybody in here in the biogas market? You are? Perfect. Yeah, so that's another one of those markets that's really kicking off and really kind of taking over the analytical world of not only contaminants, but just gas chromatography as a whole. So this page right here, we talked about the features comparison with H2S. So on the ABB, it's multi-contaminant. It can do H2O and CO2, and upcoming will be O2 as well. Right there, sideline comparison, it's right there with the SS2100 for H2S. AMI 3010 is H2S only, and then nVent is H2S total sulfur. So when we look at the response time for H2S, we're getting 10-second data. E&H, they have no spec on what the timeline looks like for them. AMI is 120 second, and then nVent is 20 second. And I won't kind of keep going and boring you to death with all the details, but as we go through this, you can kind of see where this technology, where this product wins in the market, especially of the need for multi-contaminants. All right. So on the service comparison side, so what happens if you take a liquid slug and you take on some liquid and pump one, takes that heat and goes to the front. So the way the technology, the way this thing is built, you have three pumps. Pump one is running current. Pump one takes a hit, pump one starts getting. This thing recognizes it, goes ahead and switches over to pump two. Pump one alarms out and says, hey, I need to leak at a focal point, I need an alarm, and then pump two continues to run. It doesn't try to recycle back to pump one, anything like that. It stays on pump two and protects pump one. Say 2 days later, you get an alarm and pump two is now on pump three. So now you're kind of in panic. What do I need to do? How do I replace this? So ABB does not recommend or does not sell the individual components where they want you in the field on the tailgate of the truck, taking this thing apart, breaking apart the pump, reinstate it, reinstall it. They do, however, sell a whole unit where you take the 3 Allen heads out, slide it off, slide out the full cylinder, and there's 2 connections. Disconnect those connections, slide the new one in. You send that into ABB, they do the repair, and then they'll send it back to you as a repaired and tested component. So what happens? Let's just say I take some trash in and my glass was there. Same thing. They're not saying you can't take it apart, but ABB's recommendation is if it's not a controlled environment, you're dealing with a relationship across the community. Dust can affect what's happening when the laser on that glass and things like that.
So we do that in films that we want to.
I would say yes. Now, I I do know just some technicians learning and trying to figure things out in the field where they were trying to test something and they actually damaged another component and it wasn't covered. Now, ABB's, they do have a team of technicians that they do will send out and do all the work. And we get the question, hey, if I can't work on the field, how can they work on the field? So they try to do that in a controlled environment for the repair. They're not just, walking down the tailgate, and not go around and fix it there. They'll actually, try to figure out a way to control the environment, make sure everything's clean, go back in, make sure everything's on. So, let's talk about a few of the key features on this thing. So, several of you guys have seen come on the booth. ABB in the past is known for their through the glass technology. You walk up, you tap where, through the glass where the plug is, and you can scroll through the screen. With the Sensi Plus, it is not any kind of touch or anything. It is actually hand motion maneuverability through the screen. So, one of the other features, if you have your continuous system here, it's going to state what that reading is, but if you want to see a breakout of the graph per individual component, you swipe up and go through your components and see a larger scale graph. It's got the alarm page, and then also, if your unit goes into any kind of, I would say, not failure mode, but has any kind of issue that you may have concern about, I'm not sure if that reading is right, but you can actually scan the QR code. The QR code will change every few seconds. If you scan the QR code, it'll take you to a link to my measurement system, and you can actually do a health check on that kind of device right there. So it is a multi-purpose QR code, so you can actually click the QR code link, it'll take you to the data sheet on ABB's website. It'll give you troubleshooting tips, give you ranges, gives you answers to any questions, or the main questions that you may have on the device. So these are the screens that I'm kind of showing you here. We got the main overview screen, and then we've got some individual component screens. It tells you the build date, it tells you application. It gives everything on here right here that you would need if you reached out to ABB support and they said, hey, scan the QR code, send me this, all of that information, and the health check and that current running device is sent to them. So it's no more call in, they give me the serial number, give me the expiration date. Okay, let me put this up on file. They're actually going to be able to get my readings right then, the help of that device.
Is that how they're now?
Right, so the same goes out at calibration. So most other technologies that are in contaminants are going to have a lung test, and you're going to do a calibration check, things like that. This technology does not have calibration. It does, however, have a validation check. So if you do a validation check on this device, and it's outside of that factory validation check, you can adjust the span in the software on the device itself. So any questions so far? All good? So, just a quick, took some notes of things that I want to make sure covered. It is a tunable diode laser. Doing the technology of laser spectroscopy. Every second, you're getting a 4,000 foot, 200 reading, and every 2 seconds, you're getting an output of what those 400 readings are. The field things, the manifold replacement, the cleaning of the sail and the pump. Like I said, not recommended by ABB. However, if you choose to do that, just kind of forewarning it could, and probably will avoid the warranty. So, what does the software look like? So it's running advanced software, so you can do it. And are you guys familiar with ABB's software, PCCU? So it's basically doing the background software of what PCCU is doing, but the connectivity via Ethernet is all web-based. So you log into this from factory IP of 10.1.0, you're going to have to do that. You're going to be able to visualize software to review and analyze the data. And then the back end is running the software. So we talked about the QR code being a dynamic QR code. If you guys are watching the QR, in a few seconds that QR code shifts and changes. So it's not something that somebody's going to run up to and say, 2 days later, you're not the same health check with that wants you. It's getting a lot of information in the QR code.
I believe it displays the IP address on the screen somewhere.
What's that?
I believe it displays the IP address on the screen somewhere.
Yeah, okay. So that does have the capability of turning it off for security reasons of things. It does give date time. But like I said, the IP address, once it's assigned, we'll just put there and we'll do the software and you can save it that time. It's usually actually
They're waiting for those lights.
on here.
Yeah.
I've never had a question asked.
Good track. Yes, it was.
Right. The other key things, anyways, just to require maximum 7 psi is recommended. Stay 5 to 8 psi in the day sheet. Like I said, the guy, the other guy who's going to be here teaching the class, who's knows this thing in and out from AV, couldn't make it, so he wanted me to stay 7 psi is recommended for the project. We talked about validation, so it does have span correction capability. So if you run a validation check, it's going to get from the factory where the cow look like, how does it look like now? You can adjust the span per contaminant based off the witness span.
Can that validation say, print, say anything else?
So it will,
do a report.
yeah, if you do a report, you can actually print that from that QR. And then another thing you want to do sometimes is, Daniel is in everything from biogas to upstream, some of the various contaminants and stuff, in oil and gas all the way through downstream where it's what he says he's never seen top one quality gas. But he says, on sample producing, your device is only going to be as good as what how you protect on the time. So for him, he says sample conditioning is first and foremost the most important when considering sensitive costs. He said it is dependent on site, depending on location or environment that it's put in. And then, like I said before, he doesn't recommend any of them being installed around the liquid block, just for protection. And then for this panel that you can buy with the Sensi Plus for ABB, it fits in the embedding sizes, it fits about 75% of applications as it stands for what it is. But other than that, any questions
What was the range of the O2 coming out this year?
5 to 5.5.
Yeah.
Does it have anything to do with warming clock? I know you said the temperature really doesn't matter as far as sampling. It's not going to capture that information, but let's say it is an outdoor environment, say Colorado, it's pretty cold. So if you take a hike at H2O, is that affect not only your liquid dropout, but your sample as well, in terms of temperature wise?
I think it's going to depend on the application. So it's not actually heating it in here. So what you're feeding in, I mean, ideally, you wouldn't want to install this on a rack just sitting out in the snow or sitting out in the elements. Ideally, this is made for wall mount design. If you guys want to come up and one of my over and look, it's basically two flat bars with a middle bracket design and the sample conditioning clips on the side. So ideally, you would want this in a controlled environment. That's ideal installation. I haven't seen where anyone's installed this and you've got that big swing where you've got potential for falling. And then that may be why Dale's kind of reiterates like when we look like you've got a small transmission from there to there and cover. But he would be the one that I can go to, so I can double check on that.
What is the range that can be installed? Is it on there?
Yeah, I think it's. What is it? Minus 50? That's what it's.
Very slow. Consider that.
What's the other?
I think it's 100%.
Is that a multi-commit to itself?
Yeah. So any questions? Anything you take away from this class?
Pumps. You said pump else everyone will get over, but every year it goes a week. It was initially the first pump, initially the first or second pump. Go away from to clear that or to basically go back to working or like a working manner, or we just fail and not pursue that.
Yeah, so that's what I was kind of alluding to. So if pump 1 receive a failure, and whatever they do, and pump 2 switches to pump 2, it doesn't do a check to say, hey, can I rush pump 1, try. It can be with every 270 after day, it's got to be 17 miles. So it doesn't do a check to say, hey, pump 2 stop, can you
Recess. Could you do diagnostics on your unit?
I have actually not seen multiple therapy, so.
I have.
Yeah?
Yes, we had 2 down in Texas, and we had 2 of the pumps fail, and we believe the third one fell, but I think it stays on it because it doesn't want it to fail, just in my opinion. So ABB came out, a gentleman from Oklahoma, and one from Houston, I believe, somewhere loved it or somewhere, came out and they replaced pumps, and they went and replaced them because they were the A pumps and they're supposed to be B pumps or something like that. They replaced them on the one that was working, and like a month later, the one that was working that they replaced messed up. So we had to go back out there, and the guy from Love came up and we had to do a whole new download and stuff, get it in across the working system.
Okay.
Yeah, but like what I found is like when you do a validation on the H2S and stuff like that, you turn that three-way valve to go from sugar gas to validation gas, your pumps will have a high slow. So then I let it run like that, and I have to do a diagnostic on each part to clear them out. And then I'll basically restart itself.
Yeah, so, and then, like dealers, ABB support, they're all over the US. Those guys, they're pretty quick to get out, but not only that, just having the capability to scan that QR code and then be able to just call me, or you can troubleshoot yourself with my management assistant, but then being able to say, hey, here's my health check, here's the status of this device, and then be able to see everything about the device and the current state of the TM. It's been a really cool feature from a support aspect. All right, we're right at last time. Any other questions?
What do you think of how those are running out there?
Say that again?
What do you think of how those are running out there?
Well, they're running. Since they came from pops out and looking the front line and everything, they're running.
How?
Yeah.
So I think we're on the third series of firmware upgrade. I believe it's Mitchell. He's he's out of Texas, but he's in that department. He was telling me that the 3 firmware releases before the other 2 releases. You guys aren't on the beta test for the 2 on.
No. We got it.
Yeah.
But I think what I did, like when I went and did the next one, instead of just turning the three-way valve, I regulated it down and let it come in easy. The second one did most of it, the high still won't get it along. So normally I would just open it up to that 7 pound and turn the three-way valve. Then I would start getting alarms. So when I went and done the next one, I regulated it down and I picked up the screen, that's the same thing.
Awesome.
Yeah.
Well, cool. So I need one more volunteer. Come on up. All right, then all you gotta do is just test out the play question. So
If he's an engineer, I would let him tell.
I just like it.
yeah, you are good. Just saying.
You have to have service.
That's full. So maybe the service.
Like if I go into
You try. You can scan, save, and service. Yeah, because it's taking you directly to the ABB financial system.
yeah, I'll try to but it is it's not
So we'll take a sheet of troubleshooting guide. Awesome. Thank you. All right.